Today we will be solving the linear differential equation initial value problem of x y prime minus y equals x ln of x. The initial value is y of 1 equals 2. To do this problem, we have to remember that the standard form of this equation is dy over dx plus some function of x times y equals another function of x. We also have to remember that our integrating factor is e raised to the integral of p to the x, which is this function of x right there, dx. To start this problem, we have to start by getting y prime by itself to fix this dy over dx. So we start by dividing everything by x. We get dy dx minus 1 over x times y equals, this x will cancel out, and we will just be left with ln of x. Now we are in our standard form of equation. We have our dy of dx right here. We have a function of x here times y, and we have another function of x on the other side of the equation. Now we are able to use our integrating factor. So we take p of x, which is this negative 1 over x here, and we say e raised to the integral of negative 1 over x dx. To take this integral, we know that it is negative ln of x, so we have e raised to the negative ln of x. To get rid of the e and the ln of x, we make it e raised to the ln of 1 over x, and those are equivalent. Next, we get rid of the e and the ln of x, so we are just left with 1 over x as an integrating factor. What we do with this is we multiply it through this whole equation. So we end up getting 1 over x dy dx minus 1 over x squared y equals 1 over x ln of x. Now what we're going to do here is we are going to take out this d dx right here and move it out front. What this does is, I'll show you, d dx times 1 over x times y. Now when we have this, if we actually take the derivative of 1 over x times y, we get this factor minus the 1 over x squared times y using the chain rule. So having this, we are able to get rid of that and just set this equal to 1 over x ln of x. Now that we have our equation simplified, we're able to take the integral of both sides. And another good thing about having this here is taking the integral of a derivative. They both cancel each other out. So you're left with 1 over x times y. And then you just have to take the integral of whatever on this side. In this case, we're going to use u substitution to take this integral. We're going to set u equal to ln of x, and du will equal 1 over x dx. That makes our integral, I'll move it down here, the integral of u du, which then equals 1/2 u squared. Substitute back in our ln of x for u, and we get ln squared of x over 2. That goes on this side of the equation here. Now that we have that, there is a plus c on this. Now that we have that, we're going to be solving for just the y right here. So we're going to multiply both sides by x. We're going to end up with y equals x ln squared of x over 2 plus c times x. Our next step will be to solve for this c by using the initial value we have. To do this, we plug in both of our values, so all of the x's will become 1 and the y will become 2. So we have 2 equals 1 ln squared of 1 over 2 plus c times 1. Now ln of 1 is 0, which makes this whole numerator 0. Oops. Ln of 1 is 0, so it makes the numerator 0, which makes it 0 over 2, and c just ends up equaling 2. Now we can plug this c equals 2 back into the equation we found here and get our answer. So we end up having y equals x ln squared of x over 2 plus 2x. And that is our answer.